And the new topic is impulse. New topic is impulse. The topic is impulse. Now we start the topic impulse. The topic is impulse. Now the topic is impulse. What is impulse? The impulse is what? When a large force is acting on a particle for a short time, when a large force is acting on a particle for a short time, the change in momentum is called as impulse. When a large force when a large force when a large force is acting on a particle for a short time, then change in momentum is called impulse. The impulse is what? When a large force is acting on a particle for a short time, then change in momentum is called as a impulse. The impulse is what? When a large force is acting on a particle for a short time, then change in momentum is called as a impulse. The impulse is what? What is impulse? When a large force. What is impulse? When a large force is acting on a particle for a short time, then change in momentum is called as a impulse. Note down this point. The impulse is what? When a large force is acting on a particle for a short time, then change in momentum is called as a impulse. The impulse is what? Note down this point. Now this point to be noted. The impulse is what? Impulse I. The impulse is equal to what? Impulse I equal to what? F into del T, that equal to change in momentum. This is the impulse. The impulse I is equal to what? Impulse I is equal to F del T equal to del P. The impulse I equal to F del T equal to del P. The impulse is what? When a large force is acting on a particle for a short time, then change in momentum is called as a impulse. The impulse I equal to F del T equal to del P. Yeah, we can write here I equal to F multiplied by del T equal to P2 minus P1. Even if external force acting on a particle is zero. When external force acting on a particle is very small for a very small time. When a large force is acting on a particle for a very small time. when external force when जो है when external force is acting on particle for very short time, very short time, that is tends to zero. Then जो है change in momentum when external force is acting when external force is acting on a particle for a very short time, that is very small, negatively zero, then change in momentum is zero. Then what happened? Then change in momentum. then जो है then F into del T tends to zero. F into when external force acting on a particle. When external force is acting on a particle, when external force जाओ when in the absence of external force, when no force is applied on particle, when no force is applied on particle or in the absence of force or in absence of external force. In absence of external force, what happened? When no force is applied on a particle, or in the absence of external force, F into del T is equal to zero. That means del P equal to zero. That is P2 minus P1 equal to zero. That is P2 equal to P1. It means momentum of the system is conserved. When no force is applied in a particle or in absence of external force, momentum of the system is conserved. In absence of external force, momentum of the system is conserved. Momentum of the particle is conserved. It means, note down this point, when no force is applied on a particle or in absence of external force, momentum of the change in momentum is zero. That is the momentum of the system, momentum of the particle is conserved. Note down this point. Now the next point is what? In absence of in absence of in absence of external force on particle in absence of external force on particle in absence of external force on particle momentum of the particle is conserved. That is P2 equal to P1. That means M2 V2 equal to M1 V1. Now this is all about impulse and conservation of momentum. This is all about impulse and conservation of momentum. Now the topic is conservation of momentum. Conservation of conservation of momentum. Conservation of momentum. According to the conservation of momentum, according to this law, total momentum of an isolated system is conserved. When no force is applied on a system, in absence of external force, in absence of external force, total momentum of an isolated system is conserved. According to this law, according to this law, according to this law, in absence of external force, in absence of external force, total momentum of an isolated system is conserved. According to this, what is the conservation of momentum? According to this law, total momentum of an isolated system is conserved. What is the conservation of momentum? According to this law, total momentum of an isolated system is conserved. So what is the conservation of momentum? The conservation of momentum is what? According to this law, in absence of external force, total momentum of an isolated system is conserved. What is the conservation of momentum? The conservation of momentum is what? In absence of, according to this law, conservation of momentum, according to this law, In absence of external force, total momentum of an isolated system is conserved. Note at this point, suppose at instant t1, suppose at instant t1, t equal to t1, suppose there are two positions of the, suppose at instant t equal to t1, there are two particles m1 m1 and m2 have velocity v1 and velocity v2. ठीक, suppose at t equal to t2, at t equal to t2, both particles have velocity v1 dash and v2 dash. Mass will remain same. There is no change in the mass. One instant is this and one instant is this. Okay. So suppose there are two particles m1 and m2. Suppose there are two particles having masses m1 and m2 have velocity v1 and v2 at t equal to t1, and after some time at instant t equal to t2 their velocities are v1 dash and v2 dash. Mass will remain same. Then at this point at t equal to 2 here, at this point here pt, at this point here pt is equal to what? At this point pt is equal to total momentum is what? m1 v1 plus m2 v2, and here total momentum is what? And here pt dash equal to what? m1 v1 dash plus m2 v2 dash. And here total momentum is what? m2 v2 dash. So since the total momentum is conserved, since the total momentum of the system is conserved and no force, there is no external force, hence the total momentum is conserved. So note down this point. Note down this point. Now for the hence for according to conservation of momentum, see, according to law of conservation of momentum, 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 what happened? pt dash pt equal to pt dash, that is pt is what? m1 v1 plus m2 v2 equal to m1 v1 dash plus m2 v2 dash. This is the law of conservation of momentum. So what is the conservation of momentum is what? According to law of conservation of momentum, total momentum of an isolated system is conserved in the absence of external force. According to law of conservation of momentum, According to law of conservation of momentum, in the absence of external force, total momentum of the isolated system is conserved. Not the equilibrium of the particles. The equilibrium of the particle. Equilibrium of particle. Equilibrium of the particle. And the topic is equilibrium of the particle. For equilibrium of particle, concept is what? For equilibrium of particle. For equilibrium. For equilibrium of the particle. For equilibrium of particle, algebraic sum of forces algebraic sum of forces algebraic sum of forces along x, y, z direction is 0. What is the equilibrium of particle? For equilibrium of a particle, algebraic sum of forces along x, y, z direction must be 0. Yeah. So for equilibrium of a particle, algebraic sum of forces along x, y, z direction is 0. What is the equilibrium of particle? For equilibrium of a particle. For equilibrium of a particle, algebraic sum of forces along x, y, z direction must be 0. Note down this point. Suppose this is the x, y, and z direction. See, there is one force here. Suppose there are three forces. One is F1, F2, another is along z direction मारते हैं कि F3. Suppose this angle is θ1, θ2, this angle is θ3 and so on. This is the x, y, and z direction. For equilibrium, what happened? For equilibrium of the forces, for equilibrium of a particle, A particle is placed at this point O. Particle is placed at this point O. So for equilibrium of the particle, summation Fx, algebraic sum of all forces along x direction must be zero. Second, algebraic sum of all forces along y direction must be zero. And third, algebraic sum of all forces along z direction must be zero. The for equilibrium of the particle, algebraic sum of forces along x, y, z direction must be zero. Hence, for the equilibrium of the particle placed at a point O, first condition is that some algebraic sum of forces along x direction must be zero. Algebraic sum of forces along y direction must be zero. Algebraic sum of forces along z direction must be zero. Note down this point. Lamy theorem. The next topic is Lamy theorem. Lamy theorem. In two-dimensional में क्या होगा? Suppose this is a point O. Suppose this is a point P. At point P there are three forces. Suppose at point P three forces are acting. Suppose at point P three forces are acting. This is F1, F2 and F3. This angle is alpha, gamma and beta. Then what happened? F1. The F1 upon Lamy theorem क्या है? What is the Lamy theorem? The Lamy theorem is what? According to Lamy theorem is what? Is F1 upon, इसकी अपोजिट एंगल क्या है? गामा है. F1 upon sin गामा इक्वल टू, इसकी अपोजिट F2 के अपोजिट क्या एंगल है? कौन सा एंगल है? F2 के अपोजिट बीटा है, तो F2 अपॉन साइन बीटा. F3 के अपोजिट का अल्फा है, तो F3 अपॉन साइन अल्फा. दिस इज द Lamy theorem. ये हमारी Lamy theorem है. तो दिस इज द Lamy theorem. Lamy theorem is this. F2 and this is F3. This is the Lamy theorem. अब फोर्सेस का जो इंटरसेक्शन है ये है. This is F1, F2, F3, alpha, beta and gamma. And this is the Lamy theorem. ठीक, तो F1 अपॉन इसके अपोजिट कौन सा एंगल? गामा है, तो F1 के अपोजिट एंगल इज गामा. Therefore F1 अपॉन साइन गामा इक्वल टू F2 के अपोजिट एंगल बीटा, F2 अपॉन साइन बीटा, F3 के अपोजिट एंगल अल्फा, F3 अपॉन साइन अल्फा. दिस इज द Lamy theorem, must be remembered. and this theorem is applicable in case of equilibrium of the particle. This theorem is applicable in case of equilibrium of the particle. Note down this point.